Hello, dear all engineers. Good evening. Welcome to our eighth SPE Erbil Section webinar, which is presented by Mr. Samir about the whole cleaning in drilling operation. We are pleased to present our webinar with Mr. Samir. I am Herman Zafar, student chapter license at SPE Erbil Section, which my duty is to maintain contact with the university engineering departments. All the university we have the 11 SPE student chapter in Kurdistan. And Mr. Samir is one of the our local, one of the best our local engineers, and Mr. Samir is a drilling and completion uh, supervisor with more than 14 years experience, which is working in the multiple drilling projects with the different drilling techniques such as underbalance drilling and measure pressure drilling, boom air drilling, hammer drilling in Kurdistan Region and Romania. And Mr. Samir gained extensive drilling experience due to a technical, demanding, and challenging fields. Supervised wide range of completion work over ESP running and well intervention operations. Solid knowledge and experience about the well control operation, experience in both oil and gas fields with high H2S content. Also, Mr. Samir is a petroleum engineering PhD candidate at University Petroleum and Gas in Petroleum and Gas Ploiești in Romania, and has master degree in petroleum engineering in the University of Kurdistan Hawler, Erbil, from 2008 to 2010, and has bachelor degree in geology in Salahuddin University in Erbil from 2000 and 2005, and attending wide range of engineering courses and graduated from OMV Exploration and Production Well Engineering Academy from 2011 to 2013. Also, his academic background as a drilling instructor, head of drilling engineering technology department of drilling from Noble Technical Institute, and also worked as DSP, drilling completion and workover supervisor in Taqa and Crescent Petroleum from Danagas, and started from 2019 to 2024. Also worked as well site drilling engineers from different companies, drilling companies, as OMV Petrom, Falcon Oil and Gas Company, and Crescent Petroleum. Also, he worked as QHSE engineer at GGFZ Company from 2008 to 2010. Also, we welcome Mr. Samir, and the mic is yours. Please, guys, mute your mics and mute your video calls. Mr. Samir, mic is yours. You can start and share your slides.
Can you hear me?
Yes, Mr. Samir.
Okay. Assalamu alaikum. I hope everybody is doing a good job. And good evening to everybody. My name is Samir Younus. I work as a drilling and completion supervisor. And I hope today I can share some information about drilling operation in general, and specifically we will be speaking about the whole cleaning in drilling. And I would like you guys keep your mic muted. And if you have a question, send your questions and raise your hand, and we can talk in chat and there also. Thank you very much for ESP, Erbil, and the whole team in ESP. They are really doing good job. Do you guys see my screen, Kak Herman?
Yes, Kak Samir, I see.
Okay. So we start. It will be 2 sessions, inshallah. When we will have Maghrib prayer, we stop for 15 minutes, and then we're gonna come back again. We will finish it. I have prepared, inshallah, good information from my experience, my PhD, and also a lot of literatures. Inshallah, you guys will be enjoying. First thing, we will be speaking about hole cleaning. We give you a short introduction, and then what are the factors which affect hole cleaning and the drilling problems related to poor hole cleaning. What are the problems we face if we don't clean the hole, and what we're going to do in hole cleaning in planning stage, and parameters affecting hole cleaning. What are these parameters? And hole cleaning relation with well trajectory, whether it's vertical, deviated, highly deviated, J-shape, extended reach, and hydraulic optimization, of course, the hole cleaner while drilling operations. First, we will start with introduction. So as you guys know that once we drill the hole, we need the hole to be cleaned from the cuttings. How we clean that? One of the major functions of the drilling fluid that
Kak
support
Samir,
us. Balijan.
sorry for interrupting you. Just share entire the screen, please.
I am already sharing entire screen. Actually, I was
Okay.
sharing entire screen, but that time once when I said, you told me that you can't see the whole screen. This is entire screen. And when I was moving the slides, you were not you were not following me. Do you see my slide?
Yeah, yes. It's from the
Okay.
introduction. Yeah.
Okay. So as we said, that one of the major functions of drilling fluid is to clean the hole from the cuttings which we are generating while drilling. Without cleaning the hole, we cannot go ahead and drill ahead because the string gets stuck. We cannot drill ahead. A good hole cleaning operation is important factor for every success of the drilling program. And drilling mud, we should formulate in a way that it suspends and transports cutting to the surface effectively and make the hole clean. So this is the principle. Okay, I'm gonna go to one of the wells. Let's say this our well, our hole. When we drill vertically, there are forces acting downward and there are forces acting upward. To clean the hole, I will go explain one by one how we overcome the forces which they are going downward. Okay. So first thing is the lifting force works against the gravity of the cuttings. As we said, the cuttings go down, but we're gonna lift the cuttings. What are the forces which help us to lift these cuttings, getting them to the surface, to the shale shaker, and clean the mud and circulate again, pump it again to the well? So I'm gonna explain one by one. So first thing is the buoyancy force. Okay, the drilling fluid has the buoyancy. The higher the density of the drilling fluid in specific gravity or in ppg, the buoyancy force will be higher. This is one of the forces which will work cuttings out of the hole. Second thing is the annular velocity. The annular velocity works against slip velocity. Okay, the slip velocity, is coming, the cuttings should come down, but the annular velocity, if it's fast, it pushes the cutting out of the well, and it does not allow the cuttings to be settled while we are drilling. It gives us more chance for better hole cleaning. So the more the annular velocity, the better the hole cleaning. But remember that the very high hole cleaning will lead to erosion of the wellbore and leads to washouts and many other problems which we later on. But I'm trying to go to very basic. Another thing is the yield point. Okay, the yield point of the mud is the electrical force attraction between the mud particles. Okay, this one is the carrying capacity of the drilling fluid. Okay, the yield point, yeah, one of the points which push the cuttings up, and also gel strength. It's also helping us. It's supporting us. But gravity tries to settle the cuttings. So with lifting forces, annular velocity, buoyancy, and yield point will go up, push the cuttings up, but the gravity push the cutting down. When we overcome the force of gravity and cutting slip velocity, we can clean the hole effectively. Okay, is it clear? Kak Herman, do you guys hear me?
Yes, Kak Samir, it's clear. Thank
I'm
you.
here, yeah.
Okay. So we need to monitor while operation all time hole cleaning. Okay, by observing torque and drag trend lines while we are drilling, we can make sure we can find out if the hole is clean or not. Okay, by the string movement, pickup weights, lack of weight, rotary weight, and we know if we have high torque, there's not probably good hole cleaning, and if the string weight has too much drag, we know that the hole is not clean probably. Okay, this is quantity, size, shape of the cuttings. The shaker, the shale shaker, is one of the best places to be to monitor quantity if we have a good hole cleaning. For example, you are drilling with a 20 meter per hour ROP, but on the shakers there is a little amount of cutting is coming back. You know that there is a problem with hole cleaning. So at that time you will see torque and drag, pressure goes up, many other problems. But shaker is a good place to see. Downhole measurement system, it's another aid. For example, pressure while drilling. Okay, pressure while drilling, it will give you real-time ECD monitoring. When you are drilling ahead, ECD by default slowly goes up, but not very high. You have to monitor pressure while drilling all time to see if you are getting a kick, or if you are getting a packed off, or if you are getting a poor hole cleaning. In our case, it's about hole cleaning. So when the ECD becomes very high, we know that there is a probability that the hole is not clean. In this case, what we do, we have to circulate hole clean and make sure all the cuttings is circulated out of the well. We said we're gonna monitor torque and drag, sizes and shapes of the cuttings, and amounts of the cuttings on the shakers, and also monitor downhole pressure while drilling, which it also tells us ECD. Okay, if we use peels or sweeps, it improves hole cleaning. Okay, so in rig side, we use a lot of material to viscosify the drilling fluid to increase the viscosity so that we can carry the cuttings, bring them to the surface. We have high viscosity peel, and we have low viscosity peel, and we have weighted peel and tandem peels. Many times these tandem peels are used in highly deviated wells. You pump a light fluid and then low viscosity, and then you pump a high viscosity peel behind that. This will first will wash the cuttings and agitate and make it more turbulent flow, and then the high viscosity peel will pick up the cuttings and bring them to the surface. So these are the peels and sweeps which we are using. Many times we are drilling couple stands, we pump a high vis sweep, we sweep the hole. يعني وكو بلاي جيست it will clean the hole. Okay, it's a very useful let's say technique to clean the hole, especially in highly deviated wells. We use them a lot. This is a shale shaker. Okay, this is shale shaker, is clean shaker. It's telling you probably the hole is if it's while drilling, that's a bad sign. But if it's after high vis, you clean the shaker, it means that the hole is clean. For example, before running the casing, when we drill a section, before running the casing, we need to circulate, clean the hole, make sure the hole is ready to take the casing, and then do the cement job. We pump also the high vis sweeps and clean the hole. Once they come to the shaker, the picture on the right, they will bring a large amount of cutting to the shakers. Once you see the shaker is like this in the left picture, you know that the hole is clean. Then if it's a running casing, you can run the casing. If it's ahead, you can drill ahead. There are some factors affecting hole cleaning. What are these factors? What are their impact on drilling operation? We will go one by one. So there's so many factors and players in hole cleaning. Hole size. Okay, hole size. If it's a big hole size, what happens? It will be a small annular velocity. This means that the smaller hole size is, the higher the annular velocity, the better the hole cleaning. Washout. This happens many times. Sorry. If there is washout, it happens many times in the wellbore. After you run the caliper log, you find out there is some places in the wellbore which you have circulated for a long time, or it's by default a very soft formation. It will be washed out. In these washout places, the annular velocity drops, the carrying capacity, the hole cleaning capacity will be dropped. Drill pipe diameter. The bigger is the drill pipe, the better for hole cleaning, because it will be giving you higher annular velocity, smaller annular clearance. GPM, the gallon per minute. The more flow rate, the better hole cleaning and the better annular velocity. Rotary speed. For vertical hole, it's not a big issue, but for deviated, it's a big issue. Once you are drilling rotary mode, it's already by default rotating. But sometimes in directional wells, you have to do a lot of sliding. Okay, once you do a lot of sliding, you are not cleaning the hole probably very well. So it's good to do sometimes rotary drilling and rotation, because the rotary drilling and rotation will agitate the cuttings. The cuttings will be help to push out to the surface. Mud rheology. The better the rheology, the better the carrying capacity, the better the viscosity. It's all helping hole cleaning. Okay, so we have wellbore trajectory and mud weight. Okay, here wellbore trajectory and mud weight, they are both trajectory we explained. Okay, there are three zones. The higher the deviation, the worse for hole cleaning. The more verticality has no problems. You have three zones. One zone is okay. Second zone is, let's say, from 30 to 60 degree about this area. It's very critical for hole cleaning because the cuttings will settle there and will be avalanching. But if it's horizontal, you will be permanently setting beds, cutting beds in the wellbore. That's why you have to rotate. Weight, the higher the mud weight, the better the carrying capacity or buoyancy of the mudding drilling fluid. So when you have more buoyancy, the more mud weight, it will help you to clean the well. Cutting sizes, shapes. The bigger the cutting sizes, it's the higher it has more density. Okay, it will be very difficult to clean. And the shape of the cuttings, if you have rounded shapes or flake shapes, flake shape is easier to carry them, to bring them to the surface than another type of the pipe reciprocation. It moving pipe up and down. Meanwhile, rotation, it will help cleaning. Sliding. You know, in directional wells, if you see here, it's sliding. The other way is rotary, okay? In making the well trajectory, you have to do sliding to build angle, okay? The well is vertical. If I do rotary, it will be vertical. Kak Herman, do you see my video? Do you guys see the pen?
Yes, sir.
Okay. So for sliding, for rotary mode, we are rotating the drill string. But for sliding, we are not rotating the drill string. We are only rotating the bit. So we are just moving like this. Okay. But for rotary mode, we are drilling in rotary mode. So when you do sliding, you will have hole cleaning issue all the times, because rotary mode will agitate the cuttings and help the cuttings. ROP, for sure, if you have a very high ROP that the wellbore and flow rate is not able to clean, for sometimes you have to stop drilling. Otherwise, you will get packed off and you will stuck yourself, because high ROP generates too much cuttings, a lot of cuttings in the wellbore. It's not a good for hole cleaning, and it's also not good for ECD, because too much cuttings in the wellbore, it will increase the effective mud weight, it will increase the ECD, and when you have high ECD, you will face other problems like losses. And if you have losses, you probably have well controls, total losses, other problems. So wellbore stability, of course, a stable wellbore without wash out, we explained it. Stable wash out, stable wash out, they're against each other. So if wellbore is stable, your wellbore, it will have effective size. For example, you are drilling 12¼ hole with a, let's say, 900 GPM, you will have a specific annular velocity. But if it's washing out, the wellbore, it's getting bigger. When wellbore it's getting bigger, your annular velocity drop. When annular velocity drops, your hole cleaning will not be very effective. Mud solids, once you are drilling, there will be a lot of mud solids in the wellbore, okay? So mud solids too much in the wellbore, it leads to washouts, okay? That's why you have to run solids control equipment to remove the solids. Otherwise, you will have washout. Mud solids, it will increase the PV, plastic viscosity. It's a good sign for hole cleaning. But very high PV, it means too much solids in the mud, you will have problems again. So it's all interrelated parameters, okay? What are the drilling problems related to poor hole cleaning? So once you are not cleaning the hole, obviously you will face problems. You cannot drill ahead, but before not being able to drill ahead, you face problems. What are these problems? We will go one by one. So what are the symptoms? How do you know the hole is not clean? If you go to the shaker, you are drilling with 10 meter per hour ROP, you know how many barrels of cutting you are making. Of course, the cuttings which come to the shakers, it should be more than what you are drilling in reality, because the cuttings will be swelled and become bigger in sizes many times if you don't have a good inhibition of the drilling fluid. So even if you have the same amount of cutting, you will know by default how is the hole cleaning. That's why all the time somebody is going to stay on the shakers. A good drilling supervisor and a good drilling fluid engineer always check the shaker, how much cutting is coming out of the well. You are drilling with high ROP, small amount of cutting is coming, it means that you have a problem. Another symptoms of not hole being cleaned is large amount of fields after trips. What is fields? Let's say we drilled one hole, it's 1,000 meter. We pull out to change the BHA, or we pull out to run the casing. We change the BHA, we go back, we see that it's 996 meters. It's not 1,000 meter anymore. This means that you have 4 meters of fill in the bottom. This one is telling you that you are poorly hole cleaning. You have to improve hole cleaning, okay? And that's a big problem, actually, if you have fill. This fill is a problem, always, because most of the time, the cuttings, it will be reworked, and it makes high pressure and other problems, torque and drag, many other problems if you have fills. Of course, we discuss about drag, okay, torque and drag, it will increase. And I said reground cuttings, because the cutting will be reworked. Yani you are breaking the rock by the bit, you cannot clean it very well, it will remain under the bit for a long time. You will be reworking on the same cuttings for very long time. It will damage the bit, it will prematurely dull the bit, and it will be facing problem for casing setting depths. Because many times we have seen poor hole cleaning. You run the casing, you see that there is 3-4 meters of cuttings on the bottom. That's a problem. It means that your casing will never be on bottom where you planned. Of course, we said the poor hole cleaning, you can see it by ECD, okay? You can see the ECD. If you have PWD in the BHA, pressure while drilling, it will tell you pressure close to the bit here. What's the pressure downhole? Your mud, normally if it's 12, let's say ECD while drilling, it gives you 12.2. But if ECD is 13 ppg, that's high. So you need to know that the hole is not clean, okay? The problems can be minimized by good management of annular velocity, drilling fluid viscosity, pipe rotation, and pipe eccentricity. Pipe eccentricity and pipe rotation speed, most things apply in the highly deviated wells, okay? The last 2 points, more highly deviated wells. Let's see how the annular velocity improves hole cleaning. This is the annular velocity and flow rate. This is a simulation, okay? Let's see for 11 3/4 casing, okay? 11 3/4 with pumping 800 GPM, 11 3/4. What will be the annular velocity? It will be 200, okay? Okay. Now let's increase the hole size or casing size to 20 inch. Let's see how it will be with the same GPM 800. It will be 50. So the annular velocity for 5-inch drill pipe inside 11 3/4 casing or hole with a 20-inch, you see that there is a big difference, huge difference. In this case, you have to reconsider the size of the hole, the size of the casing, and the size of the drill pipe. You can use a bigger drill pipe size or smaller size of casing, or in case if you have a liner prior to this 20-inch hole, you have to run tieback to reduce the size and improve hole cleaning and annular velocity. Is it clear so far? We talked
Yeah.
about drilling
Yes,
fluid
Mr. Sami.
viscosity. It's improving the hole cleaning. At the same time, it will lead to washout. Pipe rotation, if you have horizontal or extended reach well or highly deviated, you have to rotate the pipe to agitate the cuttings to help the mud to bring the cuttings to the surface. Pipe eccentricity, how the pipe is centered in the wellbore. The more centered, the better for hole cleaning. In deviated wells, the pipe laying down in the low side of the well, that's another issue. But once you are rotating, you are agitating the cuttings and it will improve hole cleaning, okay? So if you cannot remove the cuttings, there's so much problems will happen. What are these problems? Some of them we already talked about. We said you will have a high torque and drag on drill string. So if you have high torque, what does it mean? It means that you are getting close to the torquing makeup torque of the drill pipe, let's say. So if you drill pipe torque is 25,000 foot-pound, drilling torque more than that, it's impossible. It's very high because you're torquing the whole string and you lead to twisting drill string. يعني it's a twisting يعني ده يبسني, okay? Let's say this is a drill pipe. You are drilling ahead. There's too much cuttings on the wellbore. The more torque and drag it means چشد لو دروز دکا لبرزونزم کردنەوەی, okay? But torque چشد لو دروز دکا لسوراندنی, okay? لروtation. So you might get to the twist off يعني drill pipe twisting of maybe bipsetin, okay? So torque and drag means you get stuck, okay? Of course, that's a big problem. Whole
تۆرک
pack.
ڕانەوەکەی دیکە مشکلە بۆ تو سەرانی زیاتر ئەزی بووە تراگیش بەرزونزمیەکەیت.
Okay, so the whole pack of course, more cuttings in the hole, you might get packed off. What's the packed off? That's the wellbore, that's the drill string. When the wellbore is packed off, it's closed around the drill pipe. You cannot rotate, and you might be able to rotate, but you will not be able to circulate. So the hole is completely packed off. Lots of time you cannot even rotate, but the biggest problem is circulation. Once you don't have circulation, the hole is packed off, it means a big problem. It's a stuck pipe issue. Formation breakdown. If you have too much cuttings in the wellbore, we said you might increase the ECD very high until you get to the point where the ECD is close to the fracture gradient of the formation. You know, when we do a well design, you have fracture gradient and pore pressure, two lines, okay? Two lines. Between these two lines, you design your drilling fluid. It will be higher than the pore pressure, lower than the fracture pressure. So if the ECD goes high, you might break the formation. That's a big problem. This means that you will have losses. And in case if you have total losses, you will get to underbalance. Once you get into underbalance, you might get a kick. You will get into well control situation. So poor hole cleaning might lead you also to well control situation. Slow rate of penetration, ROP, and slow drilling. Of course, because there's too much cuttings in the wellbore, there is a lot of torque, there is a lot of drag, there is a higher ECD, you are reworking the cuttings, drilling the cuttings again and again and again, you damage the drill bit, and mechanical pipe sticking. Of course, if you as we mentioned, hole pack off. If you are not cleaning good, this means that you might get to a stuck pipe. Premature bit wear. we said because there will be too much cuttings under the bit, you are not cleaning efficiently, and you are reworking on the cuttings. Many times when this cutting coming to the surface on the shaker, you see the cuttings, it's rounded, the cutting is all rounded, you know, it's polished cuttings. You know that there is a problem with hole cleaning. In this case, you have to adjust mud rheology and you have to start pumping sweeps. Formation fracture. Of course, we talked about formation breakdown and formation fracturing due to higher ECDs, excessive overpull on trips. Okay. When there is too much cuttings on the wellbore, the wellbore is not cleaned. Let's say you do a wiper trip. The string weight is, let's say, 150 kilopound, 150 kilopound total string weight. But once you pull the string, it will be 175 kilopound. That's a drag. This drag is not all of it from the wall of the hole. Maybe it's not, the hole is very clean. Okay. Difficulties in logging and cementing. Of course, too much cutting is in there, you are not able to run the logging tools. Too much cutting is there, you cannot run the casing to bottom, and you will have problems while cementing, because even while pumping cement, you see that there is still some cuttings coming. That's why we showed the picture of the shale shaker prior to logging tool run, prior to casing run. You have to make sure the wellbore is clean from the cuttings. Casing landing, we mentioned that. That's your casing, that's your wellbore. There is 200 meters, you run, and then you see that you cannot run the casing all the way to bottom. This there is possibility to have fill. In this case, either you pull out the casing, or if you have overdrive casing running CRTs, you can rotate the casing and you can circulate slowly and clean the hole while running casing. This means that you are wasting a lot of time, and wasting time at the rig site means wasting money. So you have to be careful about this one. Prior to run the casing, first you have to make sure the wellbore is clean, all the cutting is pumped and circulated out of the hole. Stuck pipe, we talked about the stuck pipe. You might get stuck because of hole pack off and other issues, high drag and other issues related to not cleaning the hole properly. Of course, when you get to the stuck pipe, you will be doing fishing job. And once you get to the stuck pipe and fishing job, this is out of scope of drilling program. This means that you are doing NPT, non-productive time. Once NPT is too much, the upper management, the drilling manager, the drilling superintendent, everybody is not happy. The company is not happy. You are spending a lot of money. You're losing a lot of time, because stuck pipe and fishing needs a lot of money, a lot of time. You might not be able to fish the drill string. You might cut the pipe and cement the pipe in place, put another cement on top, do a sidetrack, drill another hole, and this might cost you a couple $1 million. So it's all NPT. So the hole cleaning is very, very important topic. If you are drilling supervisor, drilling engineer, senior drilling engineer, and the drilling superintendent, you have to make sure that the hole is getting cleaned while drilling. Otherwise, all these problems will come one by one probably, and you face a lot of problems. So efficiently drilling, it's a good for drilling the well on time and budget. Hole cleaning in well planning stage. This is a very important point. Anything you do while well planning, it's better than doing it on location. For example, flow rates. okay, you have to design flow rate, mud rheology prior to drilling the well. Because prior to drilling the well, it's part of well planning. But after that, on location, it's not part of well planning. Once you do adjustments, you are wasting time and wasting money. So it's better to do everything in planning stage, like flow rate. For each section, what will be your flow rate? Okay. Okay. So in well planning stage, once you design hole angle, hole size, hydraulics, bit hydraulics, mud pumps, slide drilling, BHA casing program, planning tools. What are the planning tools? And hole cleaning charts, stuck pipe guidelines. All deviated well require high annular velocities. Okay. Deviated well, of course, it requires high annular velocity because we said it's very difficult to clean the hole, and plan large diameter hole set to vertical. That's a good point, actually. You have to make sure when you are doing well planning, make sure the vertical well should be bigger sizes. Okay, put the bigger size of hole in the vertical sections, the smaller ones to be in deviated. Why? Because it's very difficult if the hole size is especially 26-inch hole or 24-inch hole. It's a very difficult to clean because the annular velocity will be very low, and the mud weight is also low because in top sections the fracture gradient is very low. That's why all time when you design wells, when you plan wells, when you drill wells, the bigger hole sections on surface, the mud weight is low because the pore pressure is low, the fracture gradient is low, and the hole diameter is big. You need big flow rate to clean this section. That's why it should be as vertical as possible. Okay. Hole size. Minimize hole sizes where possible to maximize hole cleaning. For example, I am drilling in, let's say, in Qaradagh field, but you are drilling in, let's say, Chamchamal. It's a two different field. My reservoir in Qaradagh, it's in 2,000 meter. Your reservoir in Chamchamal, it's at 4,000 meter. For me in Qaradagh, to get into my reservoir, I might need only 3 sections of casing. This means that I can start with a small size, for example, 16-inch hole. And then I run 13.38 in Qaradagh. And then I start 12 1/4 hole. I run 9.58. And then I can drill an 8.5-inch hole. I can either have it open hole or I can run 7-inch casing or liner. So in 3 sections, I drilled Qaradagh because it's only 2,000. But in Chamchamal, let's say if it's 4,000 meter, I might need 6 sections of casings. In this case, my reservoir is deep. I need a lot of casing sections because the pore pressure and fracture gradient regimes, I have a lot of zones. So I have to start with 26-inch hole. There's places, for example, in Binabari, we drilled with a 36-inch hole. We run 30-inch casing. And then we started with a 26-inch hole. We run 20-inch casing. And then you can drill 17.5-inch. You remember I said in Qaradagh, it was example. You see, I run 3 casings. I'm still didn't reach Qaradagh case, okay? So in this case, I need more hole sizes and more sections. So hole sizes, it's also a very important factor in hole care. Hydraulics. For flow rates, okay, you have to design flow rates, large diameter drill pipe. For example, You can use 578 drill pipe, 5.5 inch drill pipe, or 5-inch drill pipe, and you have to have a good MWD where it has minimum restrictions in motors, and drill collars should have a bigger IDs. Many times a flow kit in the MWD and motor, it will restrict you with the flow rate. Okay, so that's a problem. You have to plan hydraulics to give you a better flow rate for top hole and higher pressures for down holes, and hydraulics like nozzle size and number of nozzles, planning annular velocity, planning ROP, all these jet impact forces, jet nozzle velocity, hydraulic horsepower. There are softwares, there are hydraulic Excel sheets that assist in bit hydraulic design and selections, because big part of hole cleaning, it's related to hydraulic optimization. Mud pumps should be able to give you the horsepower and the flow rate which you want. The liner sizes, the bigger the liner size for whole section on the top, the bigger the flow rate, but gives you less pressure. But for deeper sections, you need a smaller liner sizes with higher capabilities of pressures. Okay. Slide drilling. As we said earlier, that the slide is a big problem for hole cleaning. The more you slide, the less you are cleaning the hole in deeper sections. So it's better to have sliding little bit and then rotary mode, sliding and rotary, sliding and rotary. We said in vertical section, you are always doing rotary drilling, always rotary drilling. But in highly deviated wells, extended reach wells, J-shaped wells, you have to build angle, no more vertical. You have to make angle. To make the angle, you need motor, RSS to build the angle. To build the angle with motor, you need to have, let's say, sliding drilling. Slide drilling, it means the string is not rotating. It's only the bit is rotating, okay? BHA should be simple with a high bypass area to assist tripping in and out of the hole. And sometimes high bypass area will reduce the annular velocity, but also reduces the ECD. So there is a lot of interrelated stuff. For example, a drill collar, let's say 11-inch drill collar for 26-inch hole. It's a very big for increasing your annular velocity, but at the same time, once annular velocity is increased, it will increase the ECD. Increasing in ECD, we said it will take you to other problems, such as fracking the formation, leading to losses, and this kind of stuff. Rat holes, while casing, you have to plan rat holes minimum, okay? If you have a 4,000 meter of hole, try to make sure your rat hole is very little, like let's say half meter or 1 meter maximum. Why? Because below the rat hole, you will be drilling, below the casing shoe, you will be drilling another size of the hole. What does it mean? Let's say you drilled 12 1/4, you run 958 casing, but after that you drill 8.5-inch hole. Below the casing you have still a hole, a rat hole, which is 12 1/4. This means that it's full of cement. It's a below casing. When you start the smaller hole, a lot of chunk, big pieces of chunk of cement will fall down into the well bore. It might lead to a stuck pipe. It might lead to hole problems. So hole cleaning tools such as charts, softwares, guidelines, stud pipe handbook, landmark softwares, flow and hydraulic optimization tools. They are all there. Like a drilling engineering application, a lot of them available. Okay, so you can use them for improving hole cleaning while planning stage. Okay, parameters affecting hole cleaning. So there are lots of parameters affecting hole cleaning. Once you understand these parameters and improve these parameters while planning stage, or some of them on the rig site, you can improve hole cleaning. So it's very useful to understand what kind of parameter affects hole cleaning and what kind of interrelated criteria involved in these parameters. So well profile, okay, well profile and geometry. Well profiles, you have vertical profiles and you have deviated profiles. Okay, vertical profile, no problem with hole cleaning. Deviated profile, big problem with hole cleaning. Cuttings and bed characteristics. Cutting bed and its characteristics in especially in horizontal wells. When you drill like this, you came vertical, you became like this, there will be a lot of cutting beds here. So once these cutting beds accumulates and gets hard, it's very difficult to clean them. Flow parameters and mud properties. Okay, this is I think because of this it's not clear. This is flow parameters and mud properties. Flow parameters like GPM. What kind of GPM you are pumping? I mean gallon per minute. Flow rate. For example, in surface hole, it's a big hole. You need high flow rate to have maximum annular velocity to help the cuttings to be lifted to the surface. For smaller sections, you have less GPMs, gallon per minute. For example, for 26-inch hole, the higher the better. Let's say 1,400, 1,500, if you can. If the rig pump and rig pressure allows you to pump this much, it's good. But for 6-inch hole, if you pump 400, it's perfect. If you pump 300, it's no problem. I've drilled with 250 GPM in 6-inch hole. 250 GPM, good hole cleaning, no problem. Because the clearance between 6-inch hole and 4-inch drill pipe is very little. So that the velocity, annular velocity, it will be very high. The cutting will be cleaned. Mud properties, we said mud weight, yield point, viscosity and gel strengths, all these mud properties, we call them rheology. So improving rheology, it will help you effectively hole cleaning. Drilling parameters. What are the drilling parameters? Like weight on bit, RPM, mainly ROP. All these things interrelated, torque and drag. It will all tells you that these parameters have a great role in hole cleaning. Okay, now we will go one by one. So we said well profiles, it might be vertical or J shape or S shape or horizontal. Okay, the whole angle and dogleg, it has a big impact on hole cleaning. For example, let's say in this area, you see this small zone, you will have the biggest problems there, and here also, here, because the angle it's between, let's say, 30 to 60 degrees. It's a big problem. Casing and hole and drill pipe diameter, we said The smaller the clearance, we call them annular clearance, the better for hole cleaning. Why? Because the annular velocity is very high. You know the Reynolds number, okay? The Reynolds number in engineering hydraulic, you study them. This one is telling you whether the flow regime is laminar, transition, or turbulent. It has a scale, 2100, 0 to 2100, 2100 to 4000, and 4000 to higher than that. It will tell you whether the flow regime is laminar, turbulent, or transition. So the higher the flow rate, the higher the annular velocity, the more the turbulent flow, it will take you to turbulent flow. The better the hole cleaning, because the cuttings will be turbulated, but you might have washout across the soft formation. Drill string eccentricity, we talked about whether the drill string it's in the center or it's in one side, especially if it's a vertical hole, it's in the center, but if it's a highly deviated, it's laying on the one side of the well. Cutting beds and characteristics, specific gravity of cuttings, particle size, shape, reactivity with mud properties. So all these parameters interrelated between the cuttings and the mud properties, it will help you to clean the wellbore better. For example, this piece of rock cutting, it's has a specific shape which it will be cleaned inside the well easier than same shape, but if it's rounded, you know, this one will be cleaned better than this one. Okay, so the specific gravity, the cuttings which they have higher specific gravity, it will be cleaned easier into the out of the wellbore. It will be more difficult to be lifted to the top by carrying capacity of the fluid and also by the buoyancy. So the specific gravity is working against you. Okay, particle size, shape, all its interrelated parameters. Flow rate, we said it will increase annular velocity. An annular velocity profile, we said whether it's laminar, it's turbulent, it's a transition regime, it will have different profiles. Okay, mud properties, we said mud weight. Rule of thumb, never increase mud weight for hole cleaning purpose, because increasing mud weight, it has a specific window. We said it's between fracture gradient and pore pressure, the mud weight between this window. You can increase flow rate, but not mud weight, because mud weight is part of the well design, part of the casing design, wellbore pressures and hydraulics. It has a big impact on the ECDs, because once you have higher mud weight, you have higher ECDs. It might clean the wellbore, but it might lead to losses. Once you create losses in the wellbore, you are having bigger problems and bigger NPTs. You might have, as we said earlier, well control situation due to having high ECD and then fracturing the formation and breaking down the formation and then starting losses. So viscosity, especially low shear rates such as 6 RPM, it has a range between 1 to 2. So gel strength, it's good. Inhibition, what is the inhibition? For example, if it's a mud good inhibited, why we use inhibition, let's say for shale, so that the mud does not react with the formation. This is good for the formation, but for the cuttings, it's good if the cuttings inhibit it and it will be mixed with the drilling fluid. It will be dispersed in the drilling fluid and it will be mixed and it will be clinging to the surface. But inhibition as itself, as a word, it's a good for the shell inhibition. Okay. But for the cutting, it's a different story. Drilling parameters, bit type, ROP, differential pressure. What is this differential pressure? It's the pressure which we are applying to the formation by circulation, by ECD, and the formation pressure. The higher the differential pressure, the less capability of hole cleaning. That's why the underbalanced drilling, it's better for hole cleaning because of the cutting hold down effect. They call it cutting hold down effect, because once you break the rock, this cutting formation, it's holding down to it. If you apply too much pressure, it will stay there. But once there's a less differential pressure, such as we said, underbalanced drilling, the cutting will chip away faster and it will be cleaned faster. It means that the formation pressure assisted you to clean the wellbore. I said underbalanced drilling. Normally, there are three techniques for drilling. One of them is overbalanced drilling, where your mud weight is higher than the formation pressure. I mean, your wellbore pressure or your dynamic pressure is higher than the formation pressure. It's overbalanced drilling. Once there's your hydrodynamic pressure, which is your hydrostatic of the mud plus your ECD stuff, once your one is less than the formation pressure, this is underbalanced drilling. For this underbalanced drilling, it's a completely different method of drilling, completely different setup of tools and equipment on surface, and like separators, like nitrogen unit on surface, like choke, automated choke, and drilling fluid system will be lighter fluid to assist you drill in underbalanced mode to make it cleaner the hole. It's a good for hole cleaning. Okay, and another third one is MPD, managed pressure drilling. It's all about your fracture gradient, your pore pressure. Once your mud weight is very close to fracture gradient, it's very higher than your pore pressure, it's overbalanced. When it's your mud weight, it's below the pore pressure, it's underbalanced. Once you are always close window between them, very narrow window, you try to drill between them, this we call them managed pressure drilling. It's very close to underbalanced drilling, but we are not going underbalanced. Pipe rotation, we said pipe rotation, it's very important for hole cleaning, especially in highly deviated wells. And I think we are getting very close to finishing our first session, because after 1 minute there will be Maghrib prayer. We're gonna stop at Maghrib prayer, if you guys don't mind. And then after that, we will continue for short time. We will finish the presentation, and then we will have, inshallah, useful discussion between ourselves. We share our experience with each other. Of course, everybody has different types of experience. Brothers in ESP, if you don't mind, we're gonna stop. Now it will be Maghrib prayer. We're gonna pray, and after 15 minutes, we're gonna come back. There is a lot of good stuff left, inshallah. It will be not very long. Mostly, it will be highly deviated stuff. Inshallah, it will be not very long. We will go through them one by one, and then inshallah, it will be useful again.
Inshallah, just one thing, guys. I saved your all questions. While we come back at the end of the webinar, we will answer all questions. Mr. Sami will read all. I will read all questions.
Okay, just please bear in mind that inshallah we try our best to answer all the questions. I'm here available. I can stay with you guys. We can speak by telephone, anything like that. For it will be fine with me. But once we come back, we're gonna go ahead with our presentation. After that, we will be open for discussions, inshallah. I can also see the questions. Kak Herman, you make let's say a special word file for all the questions. We go on by one, inshallah. Tamam?
Yeah, inshallah. Inshallah. I will save all questions. And I
Okay.
didn't close the meeting.
Okay,
don't close.
15 minutes will be good to come back, let's say at 7:30.
Yeah.
And
Yeah.
then we can
Yeah.
continue for, let's say, 45 minutes or little less or little more, and then we start discussions. Okay?
Yeah. Okay. Inshallah.
Okay, guys. Thank you very much.
Thank you, guys.
Еще на видео. No matter, I don't unmute way.
كاكرمان ديارة
بەڵێ کاک سەمیرجان
دەست خۆش بجانەکەم.
سەلامت کاک سەمیرجان.
با دەست پێکەین. بسم الله الرحمن الرحيم. I'd like to speak in Kurdish sometimes, but the problem is I don't think everybody understands Kurdish. I'm sorry for that. Because I'd like to deliver the material in Kurdish so that lots of people understand better in mother language. Anyways, I'm ready. If somebody has a question or concern, we can talk about it in Kurdish, okay? In previous session, we talked about hole cleaning, importance of hole cleaning, factors affected by hole cleaning, factors affecting hole cleaning. And in this session, we're going to continue for probably 45 minutes or 1 hour. And then, inshallah, we will have the session about discussions, okay? We said drilling parameters such as bit type, penetration rate, differential pressure, pipe rotation, and eccentricity will affect hole cleaning, you know. We said bit type, okay? Why bit type is affecting hole cleaning? For example, if the bit is very aggressive, it will have a very high ROP, such as PDC bit with big cutting sizes. Once the bit has a big cutter sizes, it will go into the formation rock more. It will generate more cuttings, sometimes bigger cuttings, sometimes more cuttings. So it depends what type of bit. Penetration rate, the higher the ROP, the more cuttings in the wellbore, you need to clean them, okay? Differential pressure, we talked about it, pipe rotation, and also pipe eccentricity. We talked about all of them. Hole cleaning and well trajectory. There is a very big relation between hole cleaning and well trajectory. I talked about the hole being vertical or being deviated or being horizontal. So let's go into this topic more and see how this wellbore trajectory affects the hole cleaning. At what are the zones? I put here so that you don't forget. This is the movie, The Good, the Bad, the Ugly. We have the good, the bad, the ugly. So there are 3 zones. The good one is a vertical wellbore or near vertical wellbore. Sometimes the angle is even 10. It's not a problem. It's close to vertical, 10 degrees or 5 degrees or 6 degrees is no problem. It's easy to clean it with rotation, with not rotation or anything is no problem. Zone 2 is the transition zone. This one is the empty zone. It's the problem zone. Why? Because the cutting here, where you see the mouse, I'd like to make some, let's say, drawings on the screen. Looks like I'm not able to do that. Yeah. I don't know why. Normally I should be able, but it's not a problem. So in this zone, it's the big problem because avalanching, when you have cuttings accumulated, it will slide down, avalanche. And it will accumulate until the hole size gets very small and the pipe gets stuck there, especially while pulling out of hole. The bad, it's better than the ugly, but it's still bad. So this area, it's between 40 to 60 degrees. People, they call it 30, 35, but Anyways, it's 40 to 60 degrees. Beyond the 60 degrees, when you go to horizontal, 90 degrees, it's the bad. It's the cutting bed will form, they call it permanent cutting bed. Below the drill string, it's full of cutting bed. If you are sliding, it means that you are drilling like this. Drilling like this. The cutting bed will be all the time there. But if you are rotating, you're drilling like this. So you agitate the cuttings, it will be cleaning the hole better. So this is the relation between the wellbore trajectory and hole cleaning. Vertical good hole cleaning. Transition zone, where we call zone 2, it's between 40 to 60 degrees. It's a very big problem there. When you pull out the BHA, you drilled like this and you go horizontal, like 5 kilometers, no problem. But when you pull back to where you have this curve, the high curve, you bring with the stabilizers a lot of cuttings. You push them, pull them together with you, you get stuck. You cannot move the stabilizer. That's a big problem because there is avalanching there. They call it boycott setting. Boycott is the name of the person or the scientist who studied this phenomena. In horizontal, it's a stable cutting bed all the time. You have cuttings below the drill string. That's why you have to rotate and make turbulent flow profile. We said regime. We have laminar, transition, turbulent. For turbulent, it's good to make turbulent. For the high angle or deviated wells. Okay. Let's play this little video.
Vertical hole certainly has its challenges. However, from a hole cleaning perspective, it is the easiest to clean. Normally, vertical hole cleaning is accomplished by plug flow of a drilling fluid that is designed to suspend the cuttings when the pumps are shut off. The cutting, in this case, has thousands of feet to fall before it reaches bottom.
You see, now the video was while drilling. You are drilling, the cuttings always going up, moving up the wellbore. If you turn off the pump to make a connection, add another stand to drill ahead, if this drilling fluid does not have a good carrying capacity, good gel strength, good viscosity, good geology, let's say, the cuttings will settle down. Okay? Once it's settled down, you might get whole pack of problems. That's why mud rheology has one of the biggest impact of hole cleaning. Very, very important factor. The rest is annular velocity here. Between this space, you will have annular velocity and the cuttings will move fast if this space between the wall of the hole and the drill pipe, the wall of the hole and the drill pipe, if this wide, very slow movement of cuttings, poor hole cleaning. If it's tight, very high speed of cutting movement, annular velocity, but it will lead to washout. Washout increases the hole size. We talked about that.
Fluid rheology is generally the key factor for effective hole cleaning in this
That's what we
section.
said. Fluid rheology. Improve your fluid rheology so that you can have a good hole cleaning. Mud engineers deal with this one. Mud engineers always working on the fluid rheology. They make sure our mud is in shape and fresh and good. They are doing pilot tests daily, twice or 3 times. They take all the readings for mud properties, rheological properties, okay? Okay, this is an example of good hole cleaning where all the cutting is dispersed around the drill pipes, around the wellbore. The left side. The right side is poor hole cleaning. Once you see why this is small pieces of cutting there, because regrinding all the time, working on them. So the drill bit gets dull. It affects dull grading of the bit, and it affects ROP, rate of penetration. Once you have this case, you are very, very close to get to a stuck point, because if you don't clean the wellbore and you have a lot of cuttings around the BHA right there, here, the bottom part, once you finish this stand, you make connection, you need to turn off the pump. Once you turn off the pump, all this cutting settle down around the bit. If this is high, it leads you to stuck and pack off. If it's little, if this one is little, you can find out when you made your connection. Once you start the pump, you will have a pressure spike. Once you start rotary, you will have a torque spike. Once you see these two, you have to take action. You should know that there is a feel on bottom while making connection. This is a sign of poor hole cleaning. I hope it's clear. Hole cleaning in wellbore trajectories. It's the low side of the wellbore. Suspended particle settles down when you make connections or when you do slide drilling, because while sliding, you drill like this, you don't rotate. But while rotating, rotary, you rotate, and the agitation probably helps this. Once this happens in the high angle, when we said 30 or 40 to 60 degree, there will be avalanching and pack off of drill string or drill pipe, because the whole cuttings fell down. Because you turn off the pump, all the cuttings turn down, get down around the drill pipe, and maybe full pack off, maybe little pack off. But that's a bad sign. So this one, you need to rotate the string, RPM, as fast as you can. Improve rheology as good as you can. Increase RPM and pump highest possible flow rate, GPM, which is the best. High GPM means high annular velocity. It will clean this. Vertical hole, we have fluid velocity, we have cutting velocity down, which is called cutting slip velocity. Cutting wants to go down, fluid velocity wants to go up. Which one is higher? That one is the winner. Tamam? This is again completely horizontal. You are drilling this way. Okay, you are drilling this way. You see, that's normal case. You are drilling this way. If you stop the pump and you pull back the drill string, pull back. These pull back, the tool joints where you see, or the stabilizers, bring all the cuttings with itself until leads to a pack off. This one you can see on the rig floor and in mudlogger screen by two things. First, actually three things. First, torque. Second, drag. Third, pressure. These three things has a trend. Let me make 3 lines. I call this torque, I call this drag, I call this pressure. If you see this paper, I have torque, drag, PSI graphs. Normal operation, there's no problem. Now, if you see PSI goes up, torque goes up, drag goes up, problem. Now I created a problem. My torque, my drag, my PSI, which is pumping pressure, whenever it goes away from the trend, if you can see this paper, it means I'm facing problem. I have to take action. What I'm going to do? I stop drilling. I have to make sure the wellbore is clean. I will circulate, I will rotate, I will pump high V sweeps, and I will reciprocate, move the string up and down. Once the things go back to normal, I will no more have the problems. Everything goes back to normal. This means that I'm a good DSV. Otherwise, I'm not a good DSV. I'm not a good team player. I have to watch all these curves all the time, okay? So we said Paco, without cleaning cuttings is a big problem. Let's play this little video.
In a vertical well, effective hole cleaning takes place when the mud's average annular velocity, which tends to move cuttings upward, exceeds the average slip velocity, which tends to drag them downward. By contrast, in a horizontal hole section, annular velocity acts perpendicular to the slip velocity, and so does not act to counteract particle slippage. The mud has to move cuttings along fast enough that they can't accumulate as they drop out of the flow stream and form a cuttings bed. The annular mud velocity for effectively cleaning a highly deviated well is generally higher than that required for a vertical well. Hole instability is another potential problem, particularly in the bend section of the hole. This requires careful attention to the mud weight and to the interactivity of the mud components with the minerals in the formation. Formation damage is an area of concern that's magnified in horizontal wells because they expose more of the formation than do vertical wells. Special attention to this aspect of drilling fluid design is, therefore, critical.
Okay, so this video was about the hole cleaning and trajectory. Skin damage is not part of the issue. It's about the drilling techniques. We talked about drilling techniques, the three ones. The skin damage will be minimum when you are drilling with underbalanced drilling. It's out of our topic, just to let you know. But with overbalanced, you will have a lot of skin damage. Skin damage is where you have the wellbore here like a skin. You are damaging the permeability around the wellbore. Thus, you will reduce production rates and flow rates when you are making the well into production, and you will create more problems. This is the rule of thumb, okay? Hole inclination and annular velocities, vertical 120 feet per minute. In this area 180, and here 240. I got this from the BP properties. Okay, this is the last session. It's a hydraulic optimization. We said that drilling engineers, senior drilling engineers, drilling fluid company and drilling fluid engineers working on hydraulic optimization. We as people on the rig site, we have to make sure that what they have planned, we are implementing correctly. For example, flow rate and mud rheological properties, mud weight, all is being optimized, and we have to make sure that we are implementing it, all of them 100%, so that we drill the well trouble-free. When we drill the well trouble-free, this means that we are drilling within time and budget. Budget, it's AFE, Authority for Expenditure. How much you wanted to drill this, how many dollars you spent on this well. Hydraulic optimization, the primary objective is to have a good hole cleaning, okay? Pumping high enough rate. Once it's a high fluid obtained, the wellbore will be cleaned, because the flow rate is one of the most important parameters in hole cleaning. We said for hole cleaning, it's not a good idea to increase mud weight, because mud weight increase, it also leads you to another problem, increasing ECD. By the way, I said ECD several times. Somebody texted, which it's Kaksoran for sure. He said, you need to tell the guys what's ECD. ECD, it's equivalent circulating density. The mud which I'm using for drilling, it's, let's say, 12 ppg. But downhole, due to the annular pressure losses, my ECD is getting higher. This means that the formation feels 12.2, 12.3 ppg mud weight. In hydrostatic mode, the mud weight, it's exactly the same as what's there on surface. Let's say 12 is 12, but when it's getting to hydrodynamic mode, it's circulation, you will have fluid pressure losses. This annular pressure losses added to your actual mud weight, we call it ECD, equivalent circulating density. Thank you for Kaksoran. He said that I have to mention this. Hydraulic optimization improves the ROP, and we have to plan what will be the ROP for each section, what will be the total depth of the each whole section, formation, fracture, gradient, and of course hole geometry. What are the hole sizes? What hole size you start first, what casing, then what second hole size, what casing, then what's the third, what's casing, and the hole angles and the wellbore trajectory, what will be the hole size, and drill string geometry, which we said about the BHA, what will be the sizes of the tools which you are running, mud gradient, and which we said mud weight, mud gradient, mud weight, what PPG, and mud rheology. Remember, mud rheology is very, very important for hole cleaning. What lithology we are going to be drilling, what kind of mud we are using for this specific lithology, what cutting gradient you will have, because the cuttings, different formations, different cuttings, different densities, different specific gravities of cuttings, all goes into the hydraulic optimization software, and then you will design the hydraulics with the softwares. This is one of the softwares. I got it from DrillSoft. There was a video. I don't know if I can play this video. I think it was here. See if I can. Let me see if I can go to. Kijk, Herman.
بالك يا أحسن.
Wallahi, guys, I'm sorry. I by mistake went outside. I don't know how this happened. Anyways, there was a video I was trying to show. Anyways, it's not a big deal. I can put the video. It's about this software, DrillSoft company. It was a good example for hydraulic optimization. But looks like when I click here. It's taking me to somewhere. Yeah. Anyways, it's not a big deal. Let's see if I can copy hyperlink, come here, and come here. I cannot. Anyways, Kakarman, Jedlema.
بلا كاك سمير.
Okay, so no problem. We don't play the video. You can play alone. It's okay. Another thing about hydraulic optimization is to make sure to keep the balance between the parameters, because there's pros and cons for each parameter. For example, high flow rate. It's good for hole cleaning, but you need high pump pressure, high rig equipment pressure, more hole washouts, more ECD, higher ECD. ECD, we said it's equivalent circulating density. So high mud density. High mud density advantage, it does not allow you to get kicks and blowouts and stable wellbore. It gives you this good stuff, but also it leads more ECD, loss circulation, lower ROP, differential pressure sticking. So you have to make sure that you use enough mud weight to be above the formation pressure and enoughly clean the wellbore, okay? And of course, below the fracture gradient. We call it mud window. We said fracture gradient, pore pressure, your mud window between. Mud viscosity, it's good for hole cleaning. It gives you low torque, drag, good suspension of barytes, but higher ECDs will give you, maybe leads you to erosion for the hole if it's too much solids in the mud. Maybe gives you high pump pressure, lower ROP, and a lot of solids in the wellbore. There is a rule of thumb, or I got this from ADCO drilling manual. So each hole size has a flow rate recommended and also annular velocity across the drill pipe section recommended. Okay, for 26-inch hole, the more is the better. Okay, because 26-inch hole, we used to pump 1400, 1500, but remember 1500 is very, very difficult because of the liner and rig capability and pressure rating capability of the liner. 17.5-inch is good, no problem. 1200 is okay. 12.25, 700 to 1000. 8.5, 400 to 650. 350 to 450. As I mentioned in one of the examples, that in 6-inch hole, you can drill with even 250, 300, 275 is okay. But this is like a guideline, like a recommendation from ADCO. They put this and I copy pasted here in my slide, okay? Okay, I will recap everything in maybe 5 minutes or so, and then we will have discussion, okay? So hole cleaning and rotary speed. The more you rotate, the more you agitate cuttings, the better you clean the hole, okay? Flow rate. The faster you pump, the higher the annular velocities, the better you clean the wellbore, okay? But your flow rate shouldn't be very high to erode the soft formations and make you washouts, and washouts it has other problems. For example, for casing running while cementing, a washout may be as big as my room. So for cementing, it's a big problem. You have to pump a lot of cement, and you don't know this washout is there if you have not run the caliper logging. Then all the cement will be inside here, the pipe will be free. Another thing, the annular velocity will be very slow in washout area, and all the cuttings will be filled there, and then you get stuck there. Okay. Mud rheology. Hole cleaning has a big relation with mud rheology. Improving rheology improves carrying capacity, like yield point, viscosity, gel strength, all these fluid properties. Even mud weight is very good for hole cleaning, but it's not considered that you go increase mud weight to clean the hole. First, you have to make sure that you are not exceeding the ECD, which it's passing the fracture gradient of the formation. Hole size, we said we plan hole sizes, and the smaller hole sizes is better. The bigger hole sizes, poor hole cleaning most of the time due to less annular velocity. Washouts, I told washout too much. My Roman cement, some example. Diameter of drill pipe, bigger drill pipe, smaller clearance, faster annular velocity, better hole cleaning. Smaller drill pipe, more clearance between drill pipe and the wall, more clearance, it means slower fluid movement, it means less hole cleaning. Well trajectory or hole angle. Vertical, perfect. Remember the bad, the good, the ugly. So the vertical is good, horizontal is the bad, the ugly is the inclined section between 40 to 60 degrees, like this one. Because the cutting here avalanches. The cutting slides down. All the cuttings are sliding down, okay? So that's why when you build trajectories, you have to make sure you have very smooth curve. Dog legs should be smooth and all these things. Flow regime, turbulent or laminar. Laminar, we talked about Reynolds number. Reynolds is the scientific who did this flow regime test, and he did a good job. He said there are 3 zones. There is a laminar, transition, and turbulent. Turbulent flow, laminar flow for hole cleaning. Turbulent flow for washout is not good. Turbulent flow for hole cleaning is good. So it's all interrelated. So turbulent flow starts with 4,000 and higher. Laminar flow, it's 0 to 2,100. 2,100 to 4,000 is the transition zone, which it's also okay for hole cleaning. Cutting sizes. We said the cutting sizes is a big, is a small, it's a density, specific gravity, all this affects the hole cleaning. Mud weight, pipe reciprocation, moving pipe and down, meanwhile rotation. Of course, moving pipe agitates the cuttings, moving pipe up is very good one. Sliding, we said we drill directional wells by 2 methods, by rotary, by sliding. Sliding is bad. Sliding does not rotate the pipe. It makes a lot of problems, okay? Penetration rate, ROP. Always, I love ROP. ROP is very good. You drill 10, 15 meters per hour, even more, it's better. But you have to make sure you are cleaning the hole. You have to go shaker all the time. You have to check you have ROP 15 or 20. Is it the same amount of cutting is coming out? You have to make sure about that. Wellbore stability and cutting dispersion. Cutting dispersion, it's like you call it tashattut, take allow. Or cutting, this cutting when it's mixed with the whole mud system, dispersion is effectively dissolving cuttings in the mud, which it will be easy to clean. But when it's not dissolving, it's not easy to clean. Okay, but this one is good for surface hole because the formation is soft. Okay, the dispersion will be very good. The cuttings will be mixed with a drilling fluid, like for example forest formation where there is a lot of clays. This clay will be mixed with drilling fluid. It will even sometimes make rheology and good, and it will clean the hole. But remember, when you need dispersion, there should not be inhibition in the drilling fluid system. For example, shale. We use shale inhibitors to make sure that there will be no swelling, no interaction and reaction between the cutting formation and the drilling fluid. So inhibition and dispersion is two different things, okay? I think it's done from my side. I appreciate your time and effort, and thank you very much for your patience. I hope that I was not very fast or very slow. I tried my best to suit with the timing because people has a lot of commitment in the night time. I am here with you guys. If there is any questions, concerns, just remember we are a group of individuals. I have lots of colleagues who are eager to support other people which they look for knowledge. We have a group, it's in WhatsApp. It's a non-profit group. It's just for knowledge sharing and free trainings. It's called Kurdish Oilfield Engineers. So we publish our activities, of course, with the SPE guys there. We always have trainings, free trainings, completely free. These trainings sometimes cost is $6,000. We provide completely free, but in future probably we will ask participants to pay like $20 or $30 just for extra costs which encounter and for charity purposes. This was the idea from some friends. Just bear in mind, this is not our first webinar and session. There are people online waiting for their turn to give us the trainings and sharing their experience. I'm very happy. I see a lot of people investing their time in such trainings. Actually, at the same time, there's people in cafes with Nergla and Shisha and TikTok stuff. It's really nice that you guys are here looking to probably learn something new or improve your skills in drilling operations. I know it's a bad time for drilling, but trust me, this experience and knowledge sharing at some points, you will see it will be really useful. And thank you very much again for SPE guys. Thanks for everybody. Kakarman, you guys go ahead.
Thanks, Mr. Sami, for your benefit webinar tonight, and thanks for these guys attended the webinar. Also, we received some questions, and I will read the questions to you, Mr. Sami. I recorded on the notepad. Someone asked for the hole cleaning. Can we use high viscosity mud, or we use?
Yeah, the viscosity, of course, it's planned by the drilling team and mud engineer. You will set your range. Let's say you say that my viscosity for a specific section is between 50 to let's say 40 at this range. Viscosity is very good for hole cleaning, of course, the viscosity, but very high viscosity, when there's lots of solids in the mud, it's bad because it will lead to erosion, washout of the wall and erosion of the pipes and washouts in the pipes and many things like that. That's why you have to make sure that the viscosity it's within the limit.
Thanks, Mr. Samir. One more question is the whole pack off is similar to the whole collapse, the same or not?
It's packed off can be due to wellbore collapse. Complete pack off can be without wellbore collapse, but it's all cuttings. So in both cases, packed off. Packed off means it's closed, packed. It means that you cannot circulate. Tamam? So it's both ways, either by cuttings, all cutting packs the drill string, or wellbore collapses, packs of the wellbore. Maybe it's any of them. But poor hole cleaning, it leads to wellbore pack-off.
Thanks, Mr. Samir. Someone needs need more clarification about that. They, for example, in different fields, you pretend the 3 casings to be used, but how we can determine the number of the casing to run? Yeah, I guess we have that terrible problem. We can't isolate it only by the casing setting. So how we can determine the number of the casing?
Is okay.
Yeah.
Do you guys see my Google search?
Yeah, we see.
Okay. This is for the person. I'd like to explain more, okay? I'd like to show you this one. What was his question? You read the questions and I will make sure. This is a very small picture. I will explain on this picture or a bigger picture. Okay, you can see this picture clearly, I think. Do you see this picture?
Yes, Mr. Samir.
Okay, this is for us, everybody, explaining drilling engineering well design. And I've worked as drilling engineer in Romania, designed many wells. You see, this is a pore pressure, okay? Red one. This is fracture pressure. As you see that I can separate these zones to 3 zones. That's why I'm running 3 sets of casings. Okay? The mud window, it's coming between the fracture pressure and pore pressure. We call it mud window. So the pressure regimes like here and here and here, it's telling me how many sets of casings I run. In Binabawi field where I've worked, there was 6 sets of casings we run. This is only 3 because the wells were deep. I'm looking for these 4 sections. Do you see 1, 2, 3, 4? And sometimes there is even more. You see this one? 1, 2, 3, 4, 5, 6 plus conductor. This is, you see, more regimes, pressure regimes, more casing string runs. Is that clear? Tamam, Kak Herman, are you with me?
Yes, Kak Samir. Also, another question about the ROP, rate of penetration. The lower of ROP cause smaller cutting in size?
No. The cutting size, just if somebody wants to know, cutting size, it has relation with the bit type and bit selection. I have 2 PDC bits. One PDC bit, it has bigger cutter size. Okay? I would like to go everything explained by picture. Okay? Do you see this bit? These are the cutters. These cutters will tell me how much I want to penetrate into the formation, into the rock. If this is big, I penetrate deeper, I generate bigger cuttings. If this PDC has a smaller cuttings like 13 millimeter cutter, it generates small. It's normally for hard formation. But if I put this one 19 millimeter cutters, it penetrates the rock deeper because the cutter is bigger and the cutting sizes will be bigger, and bigger cuttings more difficult for hole cleaning. Okay, this is the dull bit after pulling out of hole. Tamam? This is the same PDC bit. Is that okay?
Yes, Mr. Samir. Also, there's 2, 3 questions. I think they want to use the mic, but Someone asked about the using oil-based mud, using oil-based mud instead of weight-based mud can enhance hole cleaning.
Okay.
Yeah.
So there's two types. There's different types of mud systems, not two types, but mainly we talk about oil-based mud and water-based mud. Rheology-wise, water-based mud will have a really good rheology when you use it for hole cleaning. But when we talk about oil-based mud is for inhibition. Like you have shelly formations, you want to have inhibition. It's not for hole cleaning. It's for wellbore problems, which it's related to swelling and clay swelling and this kind of problems. I hope it's clear. So water-based mud is better for hole cleaning, but oil-based mud is better for inhibition. If you have shale, let's say you are drilling Kolosh formation. If you drilled with oil-based mud, is very good because of shale inhibition is very good inhibitor. Tamam? But for hole cleaning, water-based mud rheology will have a good rheology for hole cleaning. But
Thank you,
also
Mr. Samir.
other advantages and disadvantages, like for environment. Water-based mud is better than oil-based mud. Many other things for cost. Water-based mud is cheaper than oil-based mud. Things like this. Tamam?
Thank you, Mr. Samir. Also,
You're welcome.
Mr. Hamid Yusuf wants to use mic to ask the questions. Mr.
It's
Hamid,
okay.
are you here?
Hello, Mr. Sami.
Hello, Kak Hamid. Yeah, hello.
Bashi, inshallah.
Azizi, Kak Hamid. Zor spas. Thank you.
Assalamu alaikum. I have a question about a washout.
Okay.
What should we do if we have a big washout during the cementing or drilling?
Okay, so during drilling, you don't know you have a washout. You have to avoid washout. How do you avoid washout? We said don't stop circulation and pumping in one spot which is soft for a long time. And don't use very high flow rate, turbulent flow rate to wash out. During drilling, you can avoid, but you cannot see. It's difficult. You can see by one thing, okay? There is something you call tracer. You can pump tracer, either it's carbide, you can pump rice, Brent, you can pump NISC, you can pump from the rig floor and calculate how much time you need for this fluid to come back. You calculate strokes. You know how much time in reality it should be based on the hole size and how much time it's right now. Say this one, it will tell you effective hole diameter, but it will not tell you washout. If you want to find out washout exactly, after you finish it drilling, you pull out of hole, you run the caliper logging. By caliper, you will find out where is the washout zone, and caliper, it's telling you exactly where is the washout zone, how big it is. It's giving you a good idea, but to prevent it completely, it's difficult, especially where there is soft formation. They are prone to washouts. You have to avoid them. And if you have washouts, you have to account cement volume for washout. Because as I said, if the washout is very big, like my room, let's say this room takes maybe takes around 350 barrel, my room, same size as a mud tank on location. So you have to pump 350 barrel extra cement just to fill up the washout zone. Okay?
And you should fill out all the hole, like the room, if you have a under.
Yeah, Otherwise, the cement will not come to surface. I will make a drawing and I show you. Okay, let's say the hole like this, and then it become like this and like this. I'm making a drawing. Tamam. Do you guys see my video?
Yeah, it's clear.
Okay.
Guys, you can pin the video for full screen from your side. Just use the pin.
Guys, do you see this? This is a washout zone. This washout zone. This might be really big. This might be really big. So you originally planned your top of cement here. You said I top of cement. TOC, I put top of cement. In original plan, you said I put top of cement here. But if you have a washout there, the top of cement maybe comes up to here. Maybe comes up to here. All the cement comes into the wash zone. This means here it's all free pipe. And if you have high pressure here, what happens? You don't have cement there. The pressure comes and it creates problems in between the casings, annulus. You will have very bad wellbore integrity. Tamam? Is it
Okay,
clear?
it's so clear. Thank you so much, and thanks for the SPS staffs. It's much appreciated.
Thanks,
You're
Mr.
welcome,
Hamid.
guys.
Thank you. Mr. Samir, we have only two more questions. One asked about is the set of casing run determined by leak of test?
In exploration wells, when we first go to the field, there's not enough information. We rely on the offset data. We get the pore pressure from seismic and all this offset data. We don't know everything exactly, so we run more casing strings. But when we drill more wells, we do leak-off tests. Once we know that this formation strength similar to this formation strength and pore pressure-wise they are similar, we can combine this section and drill in one section. Yes, we can do that.
Thank you, Mr. Samir. Also, Mr. Ajwan wants to use the mic to ask the question. Mr. Ajwan.
Okay.
Thanks, Mr. Herman. Hello, Mr. Samir.
Hello, Kakshwan.
Thank you. I have a question about the turbulent and laminar flow. You say that the turbulent flow is much better than laminar flow to cleaning the hole. But I heard before the turbulent flow making losses of the well, pressure losses.
You remember I said in some cases it's good, in some cases it's bad. Why? For example, if you don't have turbulent flow in the horizontal section is like this. All the cuttings settle right here. If you don't make turbulent, how are you going to clean? You have to make it turbulent. You are forced to do that. But we said in vertical sections, it's better to have laminar flow, because if you have turbulent flow, because in vertical sections you will already have good hole cleaning. If you have laminar flow, you don't have the wellbore erosions, okay, and washouts. Laminar flow will create more pressure loss, 100%, will increase ECD, turbulent flow will have more pressure losses, will have higher ECD effect, but you have to do turbulent flow in some cases which you are forced by the wellbore trajectory. Tamam? You are right, it will increase the ECD, it will increase the pressure losses, but some places you are forced to do that.
Thank you. Thank you, Mr. Samir.
Kakshwan, before cement job, to clean the wellbore, you are forcing yourself to make the turbulent flow. Why? To remove the filter cake, to clean it, so that you will have better cement bond between the casing and cement, and between the cement and formation. That's why you create turbulent flow. Sometimes, old style, they were running scratchers to clean the filter cake. Tamam?
Thank you. My
welcome.
graduation project is about this topic, but I don't know why I hear it before. One more thing, Mr. Samir, can you tell me the ECD in Kurdish one more time? Sorry.
ECD, it means equivalent circulating density.
Okay.
Mud density, it's the mud density by itself. When you are not pumping, it's mud density. Let's say our mud density on surface, it's 12 ppg. If you are not circulating downhole, it's also 12 ppg. But when you are circulating, you will be in dynamic mode, you will have pressure losses. These pressure losses, it will increase effective mud density. What you believe بكردي پیدا گوتره سالاک برکار يعني او مديا استا بجوره چیتکه که زیادی کردیا بەڵام زیاد کردنەکە بەخۆی نییە بەهۆی پرێشەرەوە زیادی کردیا وەکو ئەو پرێشەرەی کە ئێمە لە FIT لیکۆفتێست بەکاری دەینین مەدوێتمان 12 بەڵام لیکۆفتێستی لە بۆ 17 دەکەین چۆن ئەوە دەکەین پرێشەری لەسەرەوە دادنین مەدەکەمان دەکەینە 17 بەبێ ئەوەی مەدیش زیادکەین ئەوەیە بە کوردی ECD ئینگلیزیەکەی equivalent circulating density density چڕیەکەیە circulating خولانەوەکە effectivەکە ئەوەیە کە چاڵاکە لە کاتی خولانەوە زیاد دەکاتن تەمام یعنی circulation دەوەرانی
دەست بۆ مامۆستاجان سپاس
جان کاک شوان
And Ms. Rojan, I think she has a question.
Okay, please.
Hello guys, hello Mr. Samir.
Good evening, Rojan Khan.
Thanks. I have a question, Mr. If you have a well and there's a formation well, swelling shell. Swelling shell expands the formation and decrease the diameter well.
Okay.
Stuck the drilling pipe. How you can improve this cleaning well and solve this problem well?
Okay. We talked about different types of mud. We said that some formations, they are shaly. You need to have inhibition in the drilling fluid. پیدا گوتره shell inhibitor موادی کیمیاویه تمام
تمام
او shell inhibitorانه chemical reaction لبيني روك بردكاو فلويدكات نايلي هبيتن يعني نايليتن reaction لقل يك بكن دي باريزيتن شيلك وكو خوي دمينيتوا كوكو خوي معه سويل نابيتن كسويل نبو مشكلة لو دروز دبي استا مثلا كيميكال كي بيدا غوتري بلاك نايت شيل انهيبيتر اتو اوي تيدكي لو نمونه دوله ستا سيل ستا لناو مدكي حتاكو او شيلا كارليك لقل ساعي الحفركي نكا اگر او كيميكال تينكت شيلا كسويل دبي كسويل بو ويل بوركا قد كدبتو كويل بوركا قد كبو احتمال ستاك بايب لو دروس كاتن يان ببردوام اتو بيست بريمين دبي لكاتي هاتنا دري وتشونو جوري فاو مشكله با مد انهبيشن علاج دبيتنو زور زور آسان شيستا لكردستان خبري بابلين فيلد كان زور برو باشي دروا مشاكل شيل زور زور كم تروغلوي بيش لبروي شيل انهبيشن بكاردينن شيل انهبيتر
زور باشه دست خوش مامستا
سرچاوان روزان بخير وي
خوش
Is there any more questions or something is not clear? Kak Herman?
Balak Sabir.
Is there anything more?
I think no. Just someone asked it about the same question which Rojan has asked it about the condition of the cleaning of the shelf formation while we have the shale formation, how
Yeah.
we deal with this. Also, I replayed that using inhibitor. So if
Exactly.
you have
Okay.
any, if you have
Exactly.
any comments
Sure.
about this, if you provide in English for these participants, we highly appreciate.
You know, I try in short time, we will start back our classroom sessions. We will be doing the courses inside the classroom. As I mentioned, we are a group of individuals, volunteer. We share our experience. We work in the fields in Kurdistan and some other countries for some other people at the same thing. We do trainings. We announce in this Kurdish WhatsApp group or I always say ESP.
No issue, Mr. Samir.
SPE, yeah, SPE. You remember Kag Rabun, Kag Herman. I always mix this ESP and SPE. So SPE guys will announce in their LinkedIn page, but we will have classroom training soon. But inshallah, we will have 2 days training with ESP guys, again online. It will be about Kurdistan drilling operation problems and sharing real experience and real problems which it happened in Kurdistan, how we deal with the problems, how we sorted the problems. But after that, we will have one of the best trainings. It will be drilling problems, day 1. Day 2, it will be stuck pipe. Day 3, it will be fishing operation. It will be inside the classroom. Because always you have problem, then you stuck, then you have to do fishing. This will be it will be a very good course for some people if they wanted to attend. We try our best to serve our people which they don't have experience, even those which they have experience and want to improve, inshallah. Tamam?
Yeah, inshallah, Kak Samir, we are glad to have you. Also, we have upcoming webinars and courses with you and with all engineers who wants to participate in this course. And we highly appreciate each words from you, from your slides that you shared with us, your informations. Guys, I think there's no more questions. If you have any questions now, please ask it. If not, you can send messages or emails to our official email and our official pages. We will provide the answers with full details. Also, about the WhatsApp group, just send a message to our page. We will provide the link, or we will add to your, or we will guide you to join the group.
About my slides, I will share all the slides. It's not a problem.
Thank you, Mr. Smith.
I share the PowerPoint. No need to make it PDF. PowerPoint is nice to put it in your computer and go through them and review them. Okay?
Okay, Mr. Samir, thanks for your time. We highly appreciate your time that you give to us.
Thank you
Guys,
very much. هیوا دارم بسود بو بیلو جماعتي وإن شاء الله بردوامش دبين. And I wish everybody good luck. I just want to say something. Inshallah drilling لكردستان دست بيدا كاتوا. أوش تشي حتمية هردبي دست بيكاتوا. معقول نيا drilling نبيتن أو نفتا بلاش لبن زيبي. أو كاتيك إيش دبينن إن شاء الله أو جورة ترينينج وبرزنتيشن أنا هم سودي لبو سيفيك دبي هم سودي لبو معلومات دبي تكامو أو شتاني كأما باز دكين همان كسي وشيمية انترفيود لقل دكاتن إن شاء الله همو تاني استفادة دكانو أمش همو دمي لخزمتين.
سپاس دەکەین کاک سەمیر گیان دەستەکان خۆش بێ و سەرکەوتوو بیت. زۆر سپاس دەکەین. زۆر سپاس بن.
موفق بن. ئەمن خواحافیز.
خوا لەگەڵ کاک سەمیر. خواتان لەگەڵ guys. Have a nice time, guys.